Welcome to lesson 1 of the third section in our crash course. We're going to discuss functions. Functions, as per the official definition, represents a section of your program that performs a specific task. One of the main reasons why functions are so useful is reusability. Once a function is defined, it can be used over and over and over again. Without having to constantly copy and paste your code, you can simply call your function. You can invoke the same function many times in your program, which saves you a lot of work. How do we define a function? Simple. To define a function, start with the def keyword. As in, we're defining a function. We're declaring a function definition. Then comes the name, the function name. I want to define a function that calculates the area of a rectangle. So I'll call it rectangle area. The area is dependent on length and width. So immediately after the name, you would put parentheses that include these arguments, length and width. The arguments, the length and width, are passed in as the function is called, where they can then be used inside of the body of the function. Let's dive into Jupyter Notebooks to see this in action. As previously noted, the first step is to obviously declare the function definition. We'll start this off with the def keyword. The function name will be rectangle area. Next comes the parentheses, which in our case is going to take in two arguments. Functions don't have to take in arguments, but we will have two of them that are length and width. We discussed this previously. And just like if statements as well as loops, to open up the block of code that corresponds to our function, we need a colon, followed by indentation. Any code within the indented space belongs to the body of the function. And what we'll do is, inside the body, we're going to set a variable name area is equal to length times width. Misspelled width. Whatever length and width that the user inputs when they call the function, they will be multiplied to obtain the area. And now all we have to do is simply return the area. Return area. We can actually do this in a single line of code by directly returning length and width and getting rid of this line. Very concise and, more importantly, reusable, because now I can simply call the function like so. On a new cell, I will call the function rectangle area. The length will be 2 and the width 3. If we print the value of our function call, the return value, what it's going to give us is the area. Run the cell and it prints 6. In essence, we called the function rectangle area, passed in our length and width as arguments, which were evaluated inside the function definition, and returned a value of their product, which was 6, thereby printing this return value. If you've ever programmed before, this should be very familiar to you, aside from the change in syntax right here. Before wrapping up this video, we can actually print the area directly inside the function. We don't actually need a return value. We can do so by first deleting this print statement here, delete the return statement, and we're simply going to print inside of our function definition length times width, the area. If I call the function again, rectangle area, this time I will pass in the same length and width, 3 and 2. The arguments that were passed in are multiplied and printed. This function obviously is reusable, so we can call it as many times as we want. I will copy and paste this function call 3 times. Let's print the area of a 4 by 6 rectangle, a 3 by 9, and a 2 by 2. Run the cell, and we get 24, 27, and 4. Perfect. All of the areas that were required. That is all for function definitions. Obviously, the logic can be a lot more complex than that. We can have all kinds of if statements and loops going on in here, but the main idea that I want you to take home is that this is a reusable chunk of code that accomplishes a specific task.